Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So now let's go to the new topic. There is a new transistor that you're going to learn for these 2 weeks. There is a metal oxide semiconductor field effect transistor, where we call this one is MOSFET. Okay. So now this is also a type of transistor. So you have 2 type of transistor. Number one is BJT and another one is MOSFET. So we will see what is the difference and why you use MOSFET instead of BJT. So the learning outcome for today's topic is to understand how MOSFET works. So there are basic structure of the MOSFET. So MOSFET still use semiconductor, and again there are 3 regions of operation, same like BJT. You have cut off, active and saturation, and the last one we're going to learn about the IV characteristic of the MOSFET. So why you need to learn MOSFET? Because what exists inside your chip, let's say this is the Intel chip, inside your computer. So it's not BJT. What exists inside the chip, the million of transistor, is actually metal oxide semiconductor field effect transistor. Why you use MOSFET instead of BJT? Because it has high integration density and it is a relatively simple manufacturing process. So due to the high integration density, that's why we can realize 10 power of 7 transistor, where in one square we have a billion of transistor, and it will lead to the low cost. So let's see what is the difference between MOSFET and BJT. So as we know previously, BJT we have 3 current, right? C, B and E. You have IC, IB and IE. So since BJT use 3 currents, it will consume a lot of power inside one BJT, and the size is quite large compared to your MOSFET. But for MOSFET, we only have 1 current. So it's a device. I will introduce you how is the device works. But it only have 1 current. So due to the 1 current, it will lead to the low power, and the device is very small. That is lead to nanometer. So nanometer means 10 power of minus 9. Okay. So it is widely used in your IC today compared to your BJT due to the only 1 current, and it lead to the low power. So this is the structure of your MOSFET transistor. So as we recall for your BJT, you have here N, P and N, right? So this is heavily doped, lightly doped and moderately doped. So here you're going to connect to your base, your emitter and your collector. But for your MOSFET, you also have the NPN. But your NPN is one at the below, the substrate. So the base here we call substrate. So your substrate is made from P-type. So what is the majority carrier for your P-type? Is a hole. So in between your substrate, we have one we call N-type and the other one we call N-type. So between this N-type, there is some also insulator there. So this insulator we call gate oxide. What does that mean by insulator? Means it cannot allow the current to flow, right? So there's a reason why they put the insulator in between the N and N-type here. So this is what we call metal oxide semiconductor field effect transistor, where we have P-type substrate, we have N-type to the source and to the drain, and in between we have the gate. So this is how MOSFET works. So in the MOSFET, the current is controlled by, from the name, right? MOS field effect transistor. So it will deal with the electric field. So what is controlling the electric field is, as I mentioned previously, we have P-type substrate, and here we have N-type and your N-type, and between your N-type you have an insulator that is called metal oxide semiconductor. So this is insulator part. So the electric field will happen at the center here. So there is some electric field happen here. So this electric field will control the current flow. So your current will flow from, this is what we call a source, this is what we call gate, and here we call drain. So your current, our aim inside your MOSFET, you need to to allow your current to flow from your source to your drain. But you know, in between your source and your drain, you have an insulator. So there is some external voltage applied here to control your electron to flow from your source towards your drain. So what is controlling here? The electric field that is applied perpendicular to both the semiconductor, means the electric field that applied at the gate. So this phenomenon we call field effect. Field effect. So how this transistor works? The voltage between two terminals, when there is some voltage controlling here to provide the electric field, and it will control the current to flow from source towards the drain. So you will understand more about this as I will explain the detail after this. Okay, so before we were talking about electric field, so let's understand first the middle one. So let me I repeat here the structure of your MOSFET. So you have the substrate is a P type. This is your substrate. In between your substrate, you have N type. And in between this N type, we have an insulator that is called metal oxide semiconductor. So in the middle here where we have MOS capacitor. So why we call capacitor? What is capacitor? So capacitor is a parallel plate, right? So same here, we have the above plate is metal, the second plate is oxide, and the third plate here is P-type substrate. So we can see here in between, in the middle of the MOSFET, we have a capacitor that is called metal oxide semiconductor. So in order to control the current flow inside your MOSFET, we have two terms of the voltage here. Number one we call voltage, threshold voltage. Number two is the VGS and VDS. So what is actually threshold voltage? Remember in your diode, you have what we call V gamma, right? The turn on voltage. How about in your BJT? So in your BJT, you have what we call VBE. So how we define VBE and V gamma is the minimum voltage to turn on your BJT or minimum voltage to turn on your diode. Then how about MOSFET? So MOSFET also we have minimum voltage. The minimum voltage to turn on your MOSFET we call threshold voltage. Okay. So this is to turn on your transistor. So but we need another two voltage that is called VGS and VDS. It's applied from the drain to source or from the gate to source. So the basic transistor principle here is the voltage between two terminals will provide the electric field and will control the current. So this is the definition of threshold voltage. So as a simple word, threshold is the minimum gate to source voltage. So remember just now we have VGS and VDS, right? So threshold is the minimum VGS that is needed to create a path. So why we need to create the path? So we want to ensure the electron, the aim here, we want to move your electron from your source towards your drain, but you cannot move easily, right? Because you have an oxide here, you don't have the bridge. So in order to provide the path, so you need to pass the threshold, means your VGS here must be greater than VTH in order for your transistor to turn on. How it will going to turn on? It will provide the bridge so the electron can flow easily, so we can have the current. So in your MOSFET, we know how to understand how the current works in your MOSFET. So we need to move from the mode of operation. So the first mode of operation inside your how it move from no current to some current, right? So we have three names here. The first one we call accumulation, the second one is depletion, and the third one is inversion. So if you recall how we put PN junction, we have some term right here. First is recombination, and then first is diffusion, and then we have recombination of the electron and hole at the junction, and then we have depletion. So same here, inside your MOSFET, we have important term here. The first is accumulation. Again, we have depletion, but the final one in your MOSFET, you have inversion.